Respected Shri G. Nageswara, Chairman AERB, Shri B.C. Pathak, CMD NPCIL, Professor K.R. online, faculty members, and the participants. Now I would like to invite guests on the dais and occupy their distinguished seats. Yes. Yeah, after that.
भैया जरा उनको बोलो ड्रेस की फोटो देने के लिए
Schema to welcome Shri B.C. Pathak, CMD NPCIL, by bouquet of flowers. Thank you so much. I would like to request Professor P.D. Naik sir to welcome all the.
Good afternoon. HBNI Engineers Day celebration on behalf of Holy Baba National Institute and my own behalf. Welcome you all for this function. In fact, you can see that many dignitaries either on WebEx or YouTube platform. Shri Nageswara, Chairman AERB, the President of CMD NPCIL, accepting our invitation to deliver guest lecture at today's function. Professor K.R. Vasudeva, VC HBNI. Ratna, Institute Professor HBNI. Ramon from NPCIL, Dureja, our beloved Registrar PC is helping, and many distributors present physically here and also colleagues from HBNI Center Office and my beloved students. That's David's message. Engineers are really the person who and the technologies infrastructure what we see today. And we should thank them for making our life more comfortable and meaningful. To our progress and to our life. And to salute this contribution made by engineers is celebrated on 15th September in memory of India's engineering icon, Sir was very highly disciplined and well known for his sincerity and dense anti-flood systems. He was known for his profound for not only Maharashtra, Karnataka, and many other states. Behalf of HBNI and my own behalf, congratulate all the engineers of India, especially engineers from day units for their exceptional contributions to India's nuclear energy programs. And many budding engineers are with us as students today for our nuclear energy programs in coming futures. Thank you all and welcome to the council.
Now I request our Honorable Vice-Chancellor, sir, to give it.
Nageswara, Chairman, Atomic Energy Regulatory Board, Pathak, Chairman and Managing Director, NPCIL, the honor, the most engineer in the audience today here. It's nice of you to have joined. Other participants, colleagues from Central Office, engineers, engineering, protection building, and remember the greatness of Sir Visvesvaraya. We will have a short just to recollect the contributions he made. Our own contributions. Training. So probably I cannot venture to general thoughts. Seems to have said once what already is, create that which has never been. This may not be, of course, fully true today, because we know that scientists do create new molecules, new materials, new drugs, and we know recently they created new vaccines. They can create things. The scientists tend to explore the natural world and works, how nature works. This is the thrust of science, whereas the engineers apply learned in order to solve practical problems on cost, efficiency, and things like that. Even this kind of difference seems to be today. You know today that there is a strong overlap between the two careers, whether it's a career as a scientist or. I can ask question, should one have a degree in engineering to be called? This I read somewhere, there's a very nice website about I love engineering. Read that There are very general thoughts about engineering, and one of them which discusses is, should we have doesn't have an engineering degree? Can we indulge in engineering? Perhaps yes again. I think there's an engineer in every one of us, even if we are by profession scientists. There's a scientist inside every engineer. You are likely to, particularly in places like, we are very likely to find scientists who design and construct equipment, who make important contributions. Today it's called as a very important discipline of science. It was founded by Prof. Shannon, who had a degree in electrical engineering and was a PhD in mathematics. We also know the importance of engineering even engineering models created. So in today's world, I would say there is a blurring of the partitions between science and engineering. Right in Mumbai, the Bandra Worli Sea Bridge is cited as one of the engineering marvels of India. The Atal Tunnel in the Rogan Pass, which is said to be one of the longest tunnels below a mountain, running something like 9.5 kilometers. The nuclear community in India has demonstrated that nuclear reactors could be economical producers of environmentally benign power in a safe manner. World records for continuous and safe operation. The future is full of interesting challenges and expansion of the power program. Technologies such as high temperature reactors or molten salt reactors or engineers for further exploration. Last year, on this day, we had Professor Shashank Chaturvedi, Director, speaking to us on the engineering challenges of the fusion program. Today, we will have an overview of the challenges of the fusion program. And to two gems of the Indian engineering community, specialists with vast experience in operation maintenance. Like you, I am also very keen to listen to them. So without any further ado, I will like to pass on the mic to Prof. Dureja to continue.
Giving a description about engineering and merging of science. For taking the journey forward, I request all our guests and VC sir and Dean sir to occupy their chairs for movie and for the program. I'd like to request our IT team to play the movie with Eva or Mr. Isa, please.
India celebrates National Engineers Day to recognize and honor the achievements of the great engineer Bharat Ratna, Sir Mokshagundam Visvesvaraya. The day is observed to commemorate the great work of engineers and to encourage them for improvement and innovation. Dreamer, thinker and a man of action, not lost in the past but always thinking of the future, living an integrated life, bringing into existence and giving shape to dreams not for himself but for India and the people of India. This was Jawaharlal Nehru's centenary tribute to Sir M.V. in Bengaluru in 1960. Sir Mokshagundam Visvesvaraya was an Indian civil engineer, scholar and statesman. He used his engineering and irrigation techniques to manage floods. He is also known for his contributions to developing block systems to avoid water wastage in dams. Apart from his engineering accolades, he played an instrumental role in imparting awareness about engineering discipline. He started his primary education in Chikbalapur, Karnataka. For his high school education, Sir M.V. came to Bangalore. He did his BSc degree from the University of Madras. He did civil engineering from the reputed College of Engineering, Pune. In 1903, he designed, developed and patented automatic floodgates, which were installed in Pune at the Khadakwasla Reservoir. Later, these floodgates were also installed at the Mysuru's Krishnaraja Sagara and the Gwalior's Tigre Dam, where he was the chief engineer. In 1908, he worked for the Nizam of Hyderabad. He tamed the floods of the Musi River in Hyderabad. He contributed to the design of the road construction that links Tirumala and Tirupati. He was also the 19th Diwan of Mysore and served from 1912 to 1919. During this period, Sir M. Visvesvaraya founded the Mysore Soap Factory, Mysore Iron and Steel Works, Bangalore Agricultural University, State Bank of Mysore and Government Engineering College. The notable works of Sir M. Visvesvaraya include development of the Krishna Raja Sagara Dam in Mysore. He also played a major role in developing a system to protect Vishakhapatnam port from sea erosion. The Mokama Bridge over Ganga was built in Bihar based on the technical advice given by Sir M. Visvesvaraya. Some of his achievements and awards are, in 1904, he got an honorary membership of London Institution of Civil Engineers for an unbroken period of 50 years. In 1906, he was awarded Kesar-e-Hind in recognition of his services. In 1911, he was Companion of the Indian Empire at the Delhi Darbar. In 1915, he was knighted by the British Indian Empire as a Knight Commander of the Order of the Indian Empire for his engineering contributions to the public. He was awarded Honorable Doctor of Literature degree from various universities in India. In 1943, he was elected as an honorary life member of the Institution of Engineers. He was awarded the Honorary Fellowship of the Institute of Town Planners, India in 1953, for his contributions to the society. He was awarded the highest civilian honor Bharat Ratna by the central government in 1955. He was a member of Board of Directors of Tata Steel for a period of 1927 to 1955. In 1958, he was awarded Durga Prasad Khaitan Memorial Gold Medal by the Royal Asiatic Society Council of Bengal. Department of Post issued a postage stamp on 15 September 1960 on the occasion of his 100th birthday. Government Engineering College, Bangalore was established in the year 1917 by Bharat Ratna Sir M. Visvesvaraya. The college was later renamed after him as University Visvesvaraya College of Engineering. Many prominent colleges were named in his honor, like Sir M. Visvesvaraya Institute of Technology, Bangalore, Visvesvaraya National Institute of Technology, Nagpur, IIT BHU, Varanasi. The Visvesvaraya Industrial and Technological Museum, Bangalore is named in his honor. When Sir M. Visvesvaraya was the Diwan of Mysore from 1912 to 1918, he transformed the state into what was then known as a model state. For his numerous industrial, economic and social projects, he was called Father of Modern Mysore. Sir M. Visvesvaraya died on the 14th of April 1962 in Bengaluru, at the age of 101. Visvesvaraya National Memorial Trust manages a memorial for Visvesvaraya at his birthplace of Muddenhalli. The memorial exhibits his awards, titles and personal belongings. Models of Krishna Raja Sagar Dam, which Visvesvaraya designed and supervised the construction of, are exhibited. Homi Bhabha National Institute pays tribute to Bharat Ratna Sir Mokshagundam Visvesvaraya.
I am profusely elated to take this to this audience, as many of them are new to the DA. Shri Ji Nageswara, Super indigenous nuclear power program in different managerial positions over the last 47 years. He graduated in electrical engineering from Jawaharlal Nehru Homi Bhabha Award recipient from 19th batch of the BRC Training School. And in the current batch is 65 and 66 batch. In early years, he worked for commissioning of the. In 1987, he was appointed as and made noteworthy contribution in streamlining on power retooling, operations and rehabilitation of both NPS units of manifold failure. During the period in Nageswara Atomic Power Station, Gujarat, his idea of having plant shut down once in 2 years, more than 90% station capacity factors. Several innovative technical improvements to resolve the equipment and grid-related outages, which have consistent excellent performance of AGS-1 world record of 962 days of continuous operation with plant load capacity factor of about 9. He served as member in High Water Board, Nuclear Tokyo Central Governing Board, and in NTPCIL Senior Advisor Safety. He is recipient of NPCIL Leadership Award, INS, and Vanu Nuclear Excellence Award 2007. Sir, to give the presidential address, please. Vasudeva.
Explain to my life, you must ensure that you are handling with that.
check the audio आ रही है वहाँ पे check करो। हेलो 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 Hello, hello. Hello, 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 hello. Presentation also, you are opening it. Full screen. Good evening to all of you. Thank you for your generous words of introduction. All my colleague dignitaries who are there with me in the dais, Professor Vasudeva, CMD, NPCIL, Mr. Pathak, and Professor Naik and Professor Dureja, and respected seniors, A.K. Anand, and all the distinguished seniors who have come here for this particular Engineers Day, and all the young participants who have come for this program. At the outset, I will share very happy Engineers Day. We are all celebrating many days, Valentine Day, Friendship Day, so many days of the many days have been introduced. I think this is a very proud day. We all should feel very happy. I think we must congratulate and also express thanks to HBNI for especially making this very informative and inspiring film on one of the very inspiring personality, Sir Mokshabandam Visvesvaraya. We all feel very privileged, and whenever we think of him as an engineer who made contributions for this country, right in the very early part of our nation, where we are all struggling to make any mark for India, especially when he was born in 1860 and in the early part of 1900. I think none of us know what the period was, how things used to be, and now it was a great honor that he could make so much of innovative contributions with the availability of resources, or with so much of lack of resources that was available, which is simply the thought power and thinking. That was the inspiring thing. Of course, when we think of thought power, we are also known to have a lot of ancient saints. We were blessed with a lot of thought power. When we think of Visvesvaraya and so many other saints, we had rich thought power in this. We are privileged to have such a very rich thought power, and we still are proud to have. That is one of our real resource India is blessed with. So with this, again, it's a good thing to look back and to share on this very happy occasion, to also how we also can inherit and get inspired, and also move ahead, and also make our own little way, some contribution as privileged or as a responsible engineers. And also how I thought when we are speaking something, instead of only through words, I also thought, had a small discussion with Professor Vasudeva. I thought I'll make some few PowerPoint slides so that something will remain in the mind instead of going away. So I think this. Okay, this is also a privileged occasion for all of us that we have been happily celebrating the 75 years of Azadi Ka Amrit Mahotsav. And we are all, this is a real proud moment for all of us as Indians, having seen the real fruits of our independence last 75 years. And all of us really, many of us have seen, not knowing that what prior to independence, how, and as a country, we have come today to this stage, and it's a very proud moment. And today, I think many of some people, when Winston Churchill, the Prime Minister of UK, used to refuse to pass on the independence to India. At some point of time, he had a strong personal view, saying that Indians will not be able to manage their country if we give the independence to them. That will be great chaos, and it is too early. We should not give them independence. That was the kind of apprehension he used to have, and he was delaying giving the independence to us. But then today we had grown in the last 75 years. That today I think UK was just we surpassed the UK in recent times. Recently, that India is the 5th largest economy in the world, and also India also this part is the second part is the third world's. India consumes oil is the third highest consumer of the oil, which is a worrying point for all of us. Because it is also causing a lot of burden on the economics, because we are all importing oil, and we don't have the oil resource, and also, of course, there are associated issues which we are all trying to come out of it. And also, we are also the produce as a third largest generation of electricity in the world, and also we, of course, with respect to the nuclear energy. In the world, there is 10% of the nuclear energy is being produced. The electricity is being produced through the nuclear reactors, whereas here in India we are only 3.2%, and there is a large focus is there to increase this share. So when you look at it, the human race, how initial period to now, how energy is playing and how we are becoming energy dependent for our day-to-day activities in the process of our development. Of course, as a human race, if you look at the other point also, of course, which is not reflected here, is that we were only 1 billion people in 1800. And today in 2022, we are more than 7.8 billion people. We are living in the same planet Earth, okay? And our activities are very much diversified compared to the olden days, only agriculture or very, very minimum activities. So several activities also requires the movement of people, extensive use of the electricity, energy, and also even we live in the tall buildings. We need to going to our own home, you need energy. And that is how, if you see in the picture, the ancient person way back in maybe several years of BC, he was only just eating food, and he himself was walking, and energy is derived only by the food. Then over the years, how the man has developed, and how the modern man, you can see how is a lot of energy being used for his transport, and also being used for his own industrial use, and various other way how we are very much consumption of energy has multifold increases there, and number of people are also increased. So that is how we are so much energy dependent, energy requirements so increased. So of course, over a period, we have also invented, humankind has also added energy sources also, right from the initial days of biomass. Later coal has been added in the early years, and later oil has joined in 1900s, and later gas has joined, and then the invention of electricity, development of electricity, generation of electricity through hydel power, and then the nuclear power, and then the now renewables, and then there is a steep increase in the energy requirements we are trying to meet through various sources, but then still energy demand is continuously increasing, and then various sources are also causing other difficulties. of causing the issues of environmental pollution and also climate change and global warming. And then there is a realization that how do we shift our energy requirements? How do we change our energy mix? And there are necessities are arising to shift our energy mixes. And then more and more focus is being given as per the international agreement to meet the or to make our climate and our planet Earth more livable for all of us. And also there is another index every country, every society is trying to make a good living is the, of course, I not mentioned here, UN is also sustainable human goals are also there. There are some 18 sustainable goals. The entire humankind, the human race is trying to work in all the countries. But generally, there is a human development index. Every country is trying to aspiring and to have a good life expectancy, a good adult literacy, and also there is a good per capita increase in income so that people's standard of living is better. So this like in Western countries, and we are also aspiring to have very good high development index. This is the aspiration of every citizen or every in the world. So with these things, we are also standing and to see that we meet these requirements and we get aligned, our citizens, we all get aligned, and we are going in a right way, as I just mentioned. That's how we have come to this stage today. So, as a part of this, right from the beginning, it cannot happen one day. So, as our forefathers on the right from the independence, we have been a very good foundation has been laid, and one of the foundation that has been laid is through the Department of Atomic Energy and DAE's establishment, and a very systematic way right from the beginning. The focus has been laid to have our own indigenous program, and very successfully. You can see from here, I think you are also aware that, of course, the veterans are here, the seniors are here. These are quite known things, and the youngsters who are here, who are now entering into the department also. You must have been knowing that right from the beginning, the indigenous focus on the indigenous design and engineering efforts have yielded over the years very good results, and now we have come very well over here. One of the very early stages, I think many of you must have been hearing, and of course we are the people at that time. I think as a senior person, I can tell you that we joined 1975. The year just after the Pokhran first peaceful explosion was done in 74. And when we joined, the scenario was very, very depressing, because that is the period when embargo was imposed. And of course, the hall, now we are all sitting. This is this campus has been, we are the first occupants of this training school hostel. 1975. This building, this multi-purpose hall, what you are now seeing was not in this shape. It is a little bit improved upon, and we were the first occupants of the building. And I was staying in 14th floor 01. My room number was 1401. I was staying I was recollecting for the youngsters. So that was the most depressing period. And most of the people used to say, what happens to this program? Because complete isolation was there. And then at that time, as such, the program has got only 2 Tarapur units were operating. And that also Whether they will operate or not, we do not know, because the US has supplied those units on a turnkey basis. Whether the fuel supplies will be there or not, we do not know. And overnight, Canadians have walked out after RAPS 1 just commissioning. RAPS 2 was under a little advanced stage of commissioning. And just MAPS 1 and 2 reactors were just planned to be started. And there was just, you can say, first pour of concrete was there. And then there is no other program at that time. So that was the status. And from that status, with the embargo restrictions, there was a big struggle. And from that struggle, the program has been progressed. I'm not saying that the grit and determination shown by our seniors to take the program forward and bring the program to the stage, that is what is the spirit which was shown earlier by Moksha and Visvesvaraya, and also taken forward by our seniors. And now you are there to see that how to move forward. That is important point we should learn from this program. So today, from that stage, slowly, we have built this capability with the thing that we should have a complete fuel cycle, complete program. That's how this program, I think you must be introduced many times, this particular slide, right from mining, fuel fabrication, reactors building, operation, and then the processing of spent fuel and proper disposal of the processing of the fuel and the reusing of the part of the extractable isotopes, as including the useful repart, and for the next stage of the program and disposal capabilities. That is how the entire capabilities have been built as per the requirements, as per the long-term plan. And then also, along with the industry, the capabilities have been also built. And this is again summarizing what capabilities have been built over the years, last 60 years. Some of the facilities are being operated by the department in industrial mode, like heavy water production, fuel fabrication by nuclear fuel complex, and then the uranium corporation, and many of the research and support facilities and the technology development by BRC, and then our own other research, IGCAR, pioneering for the fast breeder technology, and then the other advanced research centers like RRCAT and other things have been established. This is how the power program has come up. I think Mr. Pathak must be dealing later, more detailed. Just this is how in the early part from 70s, 80s, 90s, 2000, later to this date, the program has been, I will not say like a hare, but like a tortoise, this program has come. And it has been demonstrating us and kept India our own proud way with our own capabilities, we are able to demonstrate to the world. So these are the workhorses which have started right from Tarapur until today, the Kundangalam reactors and all the new reactors which are in there. Of course, the journey is not as you are seeing in the picture. Every reactor has seen certain issues, certain challenges, and that posed certain times when the issues arise. Always whenever all of us, you are all, we as human beings, when you find it somebody in our family, when you face a financial crisis or when you face a health problem, you always some uncertainty will be there, whether you will come across. Maybe recently the entire world has seen a COVID issue. So whom COVID will affect? If COVID will, you will get infected with COVID, whether I will survive or not. Then how India, such a country where there is no health infrastructure, whether India, if COVID comes in a big way, whether India will survive or not. Then what has happened? How we invented vaccines, how we managed ourselves, even our own reactors, our own people in working in the reactors without affecting the reactor operations and the things, how we managed. So always there is a way out, but that way out is not simple. Everybody has to put their efforts. Similarly, these reactors had faced problems like I say in the initial period of the Tarapur, there used to be many fuel failures. How to reduce the fuel failures, how to minimize these, how to improve the operations. And similarly, RAPS reactors also faced some problems. Similarly, MAPS reactors had faced the problem of inside the moderator manifold failures. In fact, the Canadians have advised saying that once the moderator manifold has failed, you cannot operate these reactors and almost you have to write off these reactors. So from that advice, we ourselves have done certain modifications, internal modifications with the BRC and with all the DA units coming together. And we made the internal changes initially and operated these units in a different mode, changing the inlet outlet of moderator. Later, in a different configuration of Sparger's design. And then now the units were rehabilitated and units were survived. Similarly, there was a big fire incident in Narora. Then there was a question mark that how this unit will be put back from a big turbine fire. Then these units were rehabilitated. The units were started back with our own internal resources. Like Pakarpara unit had faced a big problem of flooding in the initial startup. So when such a big flooding has happened, how the units will come back. So from the flooding incident, the units have been retrieved and then the units have started back. And these units later operated as one of the role model units. Then when the construction of Kaiga is started, then when the design change was made, and initially with the design change, there was a dome delamination was there. There was a lot of attribution that the people did not design properly. There was a lot of corruption and all that thing. So again, from that stage, the redesign was done. And then later on, the same units were reconstructed properly. And then the subsequent designs were modified. And that is how there will be setbacks. But then the setbacks are understood properly, handled properly, and proper reinforcements were done. And that is how further, like we have been sharing, the same unit of Kaiga has made a world record of continuous operation of 962 days. And that is how the resilience is shown by all of us. And similarly, the first units of Tarapur were the first units which have been built as a 500 megawatt reactors. Of course, initially certain challenges were there, but these units are the units which have been operating very well, which were totally designed by ourselves with number of new systems and other things. Similarly, when Kudangalam was adopted and with a lot of our own specified features, Kudangalam reactors, I think we must, many of the people may not be talking about it. And I think being youngsters, we must know that the VVR 1000 megawatt reactors of Kudangalam, many of the specifications, the requirements of Kudangalam specifications like 4 safety trains and then the other passive safety features requirements have been specified by Indian, by us to the Russian designers. And many of the safety features, especially for a one of the requirements where you must have been, you may not be may not be familiar, is one of the blackout situation in a nuclear power plant. Suppose if there is a total class 4 and class 3 complete power supply failure is there, how the reactors will sustain without failure. And that was precisely the reason where the Fukushima accident has occurred, because those reactors, initial design reactors, have not been provided with any other cooling resource when total power supply is failure. So that is how the core got damaged and the incidents have happened. But that thing has happened in 2011. But when Kudangalam reactors have been specified somewhere in, I think later 1990 or something, or 2000, early part of 2000, our designers have asked if such a big reactor, if there is a station blackout situation is there, these reactors should have a cooling provision and the reactor's core should not damage. So those provisions have been provided in Kudangalam reactors much before the Fukushima accident. Please remember that it is not that our people are not capable. We are much capable people, and that type of confidence we should display always. And we should not think that we cannot do anything, so we are like this. So please remember this. So now these are the new projects. Again, CMD and PCL will be talking more about this. These are the future projects which will be coming up and adding the nuclear capacity as a green power to our requirements. So of course, as I just mentioned, we all developed today the industry has also come up with all our own in-house sources. And that is how the PHWR reactors, we are going in a big way because of their our own capability, indigenous capability, as well as their economics. In addition to the nuclear power program, we have many people may not be knowing about the other applications of the radiation. Other application of radiation technologies are also there, especially through the accelerators, and they are finding it wide application in the industry. In this area also, DAE has worked and made remarkable contributions. This is just, I am showing the especially RRCAD and VCC at Calcutta, even in BRC, many of the accelerators are very different capacity. Accelerators are there, they are being extensively used. And similarly, radiation processing facilities are also developed, which are being used in many places. So I'm just mentioning that DAE pursued the non-power technologies, which all of you will be knowing even with the various other varieties of the seeds, then seeds development, and then the radiation-based post-harvest technologies, techniques for radio diagnosis, radiotherapy equipments for cancer treatment, nuclear medicine. In all these areas, DAE has contributed many in all the areas. And of course, apart from this, all these technologies are also being deployed very safely. And as regulators, we are also ensuring that these technologies are deployed in the society in a very safe manner. And these applications are there serving in the industrial area, in the medical field, in the research field, in the consumer areas, and also in the scanning facilities, and also for the security of the country in the ports and in the airports. So some of the radiation-based equipments are being used. Almost you can see entire nation, the radiation-based facilities are serving various applications. But this is just to give a glimpse how today various places, especially the radiation in the medicine area, the applications, various equipments are there, which are under regulation, which we normally assess, which we give the consents, and which are under regulatory control. Both in a broadly, they are classified as diagnostic equipment and therapeutic under therapy. So diagnostic equipments are like X-rays and nuclear medicine, and then therapy is for the treatment purpose we have. That's what it is shown over here. So when you look at it, when you are using these advanced technologies, when there are not only in the nuclear field, it is just, you can see here, even in this other industries also, you can see sometimes certain accidents do take place. Some accidents of 3 Mile Island accident in 79. You must have heard about the Bhopal gas tragedy and also Chernobyl accident. And then you have, there is a oil platform accident where the fire accident 2010 and Fukushima accident 2011. And also you must have seen some of the accidents in Boeing 737 MAX 8, 2 crashes that has occurred in 18, 19. And also hydropower plant incidents, I think recently, which has taken place in Sri, Telangana 2020. And some incidents in thermal power plants, in boiler blasts and other things which are taken in Uncha and also in Tamil Nadu lignite things. So these accidents are taking place. So I think one accident, I especially, of course, 3 Mile Island accident, probably you'll come to know. There could be some errors that may be taking place, but most of the accidents, I think I'm tempted to go through and come back again. One of them. I think when you look at this accident analysis, you see most of the reasons. Analysis tell that obviously, when the accident occurs, when post analysis says they look to be, it could have been avoided easily. So the reasons will be many times will say personal error, some design deficiency which could not be noticed, or something was which should have been some upgradation should have been done, or somebody has not followed the procedure. I think these are the very, very standard things. So can you imagine Boeing 737, Boeing company, who have been operating so many, they have designed, Boeing company is one of the very well-known company who had a number of aircrafts. I think more than 70-80% of the aircrafts are, the operating aircrafts are supplied by Boeing, and they have a number of models and many things. So when you saw that how Boeing company, when they design, how they falter, like 737 MAX, this thing. How it has how those crashes have happened in 737 MAX, and finally that such a big company has to withdraw their that particular aircrafts, from flying. You must have seen also, it is not a nuclear this thing. So I think, I don't know, this print is not very clear. There is one system when they wanted to improve the fuel efficiency of 737. So they want to have a better engine of 737. So that engine, they wanted to position it in the wings a little differently. Then they had a feeling that when they position it, when the aircraft takes off, then there is a possibility that it may not take off, it may stall. So they have designed a system called Maneuvering Characteristic Augmentation System, that is called MCAS. This system tried to point the aircraft nose down so that it could gain enough speed safely. That is the designer intention. So then what happened? So they have given two sensors. MCA takes readings from two sensors that determine how much the plane nose is pointing up or down relative to oncoming airflow. When MCS detects that the plane is pointing up at a dangerous angle, it can automatically push down the nose of the plane in an effort to prevent the plane from stalling. That is the intention of it. So it started misbehaving, and they have not given the proper training to their pilots, and then the system caused the crashes. So that is how, when some new system is designed, new system is introduced, there should be proper analysis, and then it should be done. So that is how sometimes, innocently we get into problems with the intention of improving something, overlooking something which is deceptively overlooked. So that is how lack of detailed procedures or lack of adherence to bypassing the procedures or lack of detailed training to the people and some deficient technicalities we are overlooking. Sometimes it can lead to problems. So one has to be very, 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 very cautious. But in case of nuclear power plants, there are a number of good design features, good practices are being followed. That is how the units are being operating. Nearly for India has got now more than 500 reactor years of safe operation of good track record without any major events of radiation leak concern to the public. So this is all being achieved because a strict regime of adopting the good practices of the multiple barriers, redundancy, respecting them, passive systems, all these things are being followed. And this needs to be not to be followed in terms of intention, in terms of the good spirited way in a continuous basis. That this should be the basis for the safe and long-term reliable operation. So this becomes the almost like a requirements. So as we go on operating more number of reactors, more number of sophisticated thing, so equal number of attention, and we should not lose sight of the requirements and safety. So that is how all of us should keep focus. We should never dilute it, and we should safety principles, objectives prescribed in the form of regulatory requirements have an important role in establishing the level of level of safety risk that is acceptable. So, of course, these any technology, certain requirements are there. Those requirements are to be met as per the standards. Just I have listed here, like in case of PHWR, periodically you may have to you have to carry out the NMOS coolant channel requirement replacement, NMOS feeder replacement. Sometimes the of course, in case of the steam generator replacement, and then sometimes you may have to overcome certain crisis type of situation also. So as far as the upcoming challenges are there, of course, as there is now the thinking is about the small and modular reactors, because in case of to reduce the construction time and also to have the flexibility of using bringing up utilizing the thermal stations which are being phased out. So there is a thinking which is going on. I think these challenges one has to meet. I have listed some of those new reactors, new technologies. This may have to be adopted. I think the young people may be going to work more on these areas in the coming years. You must be geared up to face these and meet these requirements. So in the world over, there is a recognition that India is poised in a better way because there's a one called demographic index. In the demographic index, the younger people's proposition compared to the old people is higher for India. Whereas in the Western countries, this index is not favorable. It means there the more old people are there, lesser younger people are there. So I think this particular strength has to be utilized well. I think we are utilizing it. I think this particular focus point is the younger generation should not waste their energies in a wasteful manner. They have to be utilized in a proper manner, and that should be utilized for a nation building, like what today we are celebrating Engineers Day in honor and the inspiration of Moksha Visvesvaraya as a single person, what he could do. And then maybe as an individual, as an younger generation, many people should determine to do and follow the footsteps of it. That is the purpose of all of us trying to spend some time over here. So please remember that. And we are much better poised in the world nations. And we are now come to this platform built by the elders. And then the younger generation should take it forward. So that is how initially I was worried when the elder people are come in time and younger people, we are waiting for you. And then more chairs are empty, and we want more young people. As the reflection of this country is dependent on what younger people are going to do. What older people exit, we are going towards the exit gate. And your distance to exit time is much more. And what you decide, what you define, what you do is having much more impact on this country. So that's what we look at you. And we are much better way poised, and you are doing it also. I'm not saying that there's nothing to worry about it. When we are trying to re-emphasize for our own satisfaction. It's not moving. So these strides, we must remember that nuclear technology is a special and unique. And as I just now mentioned, you don't have to nod everything. Somebody is superior, you have to nod and agree. So please, and again, we are talking about younger generation. So this group thinking, is avoided through diversity of thought. So we have to maintain the diversity of thought, and intellectual curiosity is important here. So why it is happening, why we should agree. If there is a genuinely something problem is there, opposing views are encouraged and considered. So you don't say that we have to say yes for everything. So this is important. And complacency, because I am doing yesterday something, so it will continue, it is okay. The complacency is one of the bad thing for anything. Don't bring in complacency into this. And all safeties are important. Nothing that only one particular system is important. Everything is important. So you have to the same things are being repeated. I think when Visvesvaraya, when I went to one institute, there was a bust, and then under the bust he has written, and you just admire his thinking. 10 commandments. So he told at that time itself, practice self-help, know that knowledge is power, cultivate teamwork, practice teamwork, increase production and services, support Indian industries, restrict imports, maintain efficient standards, think and act institutionally, think in terms of nation. So please remember, he stood for those values, and we also stood imbibe for those values. I thought I will share these things on this occasion. And also, I am also tempted, I have long association with Dr. Vasudeva. right from Kalpakan days. And I hope when he told me that he invited, that I should talk, I was hesitant who will come and this thing because of your very long association. I appreciate whatever initiatives you have taken at HBNI. As we see, especially a lot of programs you have devised, which will be useful most of the people, courses you have conducted and other thing. I appreciate and I convey my real regards to this thing, and also thanks for organizing this program also. I convey my best wishes to you also on this occasion. And I once again thank all of you for your kind attention. I wish all the good luck and happy Engineers Day. Thank you.
Thank you so much, sir, for your enlightening presentation on the evolution of nuclear power program, the way the nuclear fraternity has overcome the obstacles because of embargo, the challenges faced during plant commissioning and operation is really motivating for us. Thank you, sir. We are feeling honored to have the Chairman and Managing Director of Nuclear Power Corporation of India Limited, Shri B.C. Pathak, a man of distinct vision and a fountainhead of illuminating ideas with us today. Sir, you hardly need any introduction. You have made all of us proud of your distinguished work in numerous capacities. For the benefit and motivation of our young participants, I would like to introduce you, sir. Shri B.C. Pathak, a distinguished scientist of the Department of Atomic Energy and is currently Chairman and Managing Director of Nuclear Power Corporation of India Limited. He has contributed immensely in the implementation of nuclear power projects based on PHWR technology in India. He personifies NPCIL's enduring commitment to its values of continuous innovation, improvement, safety, and societal care. A mechanical engineering graduate from G.B. Pant University of Agriculture and Technology, he joined 30th batch of BRC Training School in the year 1986 and has earned the reputation of being a young technopreneur regarded for his abilities to set benchmarks of astounding achievements in his various assignments and leadership roles so far. Upon completing his one-year training at BRC Training School, he was assigned the job of erection of nuclear equipment and core components at RAPP 3 and 4, or from where he moved to TAPS 3 and 4 with higher responsibilities as project engineer for nuclear piping and equipment. Undaunted by the hiccups and delays in procurement, he was able to meet the schedules of critical path activities, which enabled this project establish an all-time high records of 5 years completion. He was made responsible for outdoor piping work and elevated as additional chief engineer, marking him as one of the youngest engineer to shoulder this responsibility. With his rich experience of over 35 years in project implementation of nuclear power plants of all capacities, such as 220, 540, 700, 1000 megawatt of both PHWR and PWR technologies at different sites in India, Shri Pathak now looks ahead with optimism to push India closer to its goal of self-reliance in energy by leading the most ambitious nuclear power program ever, that is construction of 10 reactors in fleet mode. In 2006, he was assigned yet wider responsibilities at KKNPP with his elevation as Chief Construction Engineer, where he led the construction and erection of KKNPP. Returning to RAPP 7 and 8 in 2012 as Chief Construction Engineer, he became Project Director of the project. He was appointed as Chief Director, Executive Director, Projects PHWR in the year 2016 at NPC headquarters and took over as Director Projects on 4th of July 2019. Shri Pathak was appointed as Acting Chairman and Managing Director of NPCIL with effect from 1st of February 2022. And on 23rd February 2022, he became the full-time Chairman and Managing Director of NPCIL. He is also Director of Anushakti Vidyut Nigam Limited, that is a joint venture of NPCIL and NTPC. A believer in professional and value-driven institution management, he yearns to be at the forefront of adopting good governance principles in his company. NPCIL today stands tall as a respected company ready to meet the challenges and use the opportunities coming on its way. So I would like to invite Shri Pathak to deliver his lecture, please.
Thank you, Professor Dureja. Respected Shri G. Nageswara Sir, Chairman AERB, Professor P.R. Vasudeva, Professor P.D. Naik, Professor A.K. Dureja, my seniors from DE family, colleagues from NPCIL, training officers, and all colleagues joining this program online. A very good evening to everyone. I wish you all a happy Engineers Day. On the onset, I thank HBNI for inviting me for this event. Since I didn't have any clear understanding what to speak, so I thought, because the audience is basically the young engineers who will be shouldering much higher responsibilities in coming days, so I thought I will give an overall overview of the nuclear power program, so that you can understand what exactly it means and what are the challenges and how you are going to take it further. My presentation will be in these outlines. I'll be discussing about the various sources, scenarios of energy, nuclear power, organization, how DAE and NPCIL involved, and what is the contribution of indigenization in this endeavor. A little bit of 700 megawatt and like that. So as you all know, these are the various sources of common sources of energy, like starting from thermal, hydro, wind, biomass, solar, nuclear. So out of this thermal, nuclear, and large hydro, they are part of base load stations. If you see the overall present Indian electricity scenario, we'll see that the major contribution today in our energy basket is thermal, that is around 60%, followed by renewables, that is around 27%, and hydro is around 11%, and nuclear for installed capacity, it's a meager 1.7%. And the other chart, which you can see how much we are generating out of this capacity of 400 gigawatt. So if you compare this renewable, the installed capacity is around 27%, whereas it is generating around 11%. And if you compare nuclear, installed capacity is 1.7%, but it is generating around 3.15%. So this is a difference. So, and the other side, the overall per capita energy consumption in the world is average is around 3,000 kilowatt hour, and USA around 12,000, and Canada is much higher, around 17,000. And whereas India, as of this 2015, it is 1075. Today it is around 1300, 1255 units. So if we want to at least go for the average, world average of around 3,000, so we need to enhance the power 3 times, minimum 3 times. So today it is 400, so around we can go for 1200 at least to have this average per capita energy consumption. So that means we have got huge capacity, a huge program, and there is growing energy demand now. And this is a typical cycle how power is generated from nuclear stations. And next one is, this is the comparison between thermal and nuclear. Basically, the source is different, otherwise the conventional systems remain same. Dr. Homi Bhabha has already envisaged this, so he made a statement: any substantial rise in the standard of living in this region that can be sustained in the long term will only be possible on the basis of very large imports of fuel or on the basis of atomic energy. So that is why we have pursued this nuclear power program, and this is how the framework of nuclear establishment basically evolved. So 1944 was Dr. Bhabha's initiative for setting an atomic research center in the country. 1945, the TIFR was set up. 47, after independence, the Atomic Energy Act and AEC Constitution was done in 1948. 54, DAE was established, and in 50s, 60s, various institutions were built, like AMD, IREL, Jadugada, Apsara Reactor, Atomic Energy Establishment, train schools, Cyrus, heavy water plant, ECL. So in different point of time, these institutions were built, followed by NFC, Nuclear Power Corporation, in 1987, BRIT, IGCAR, IPR, AERB, RRCAT. So these are the institutions which have been basically part of our DAE family. So coming to the nuclear power. So these are the various institutions involved in generation of nuclear power. So it is not only the NPCIL who is responsible for generating the nuclear power. It starts from the mineral exploration that is led by AMD. Then uranium is mined by UCIL and IREL. Then heavy water board is very important, providing us the heavy water. NFC is providing us the fuel, and nuclear power corporation is responsible for generation of the electricity, and followed by fuel cycle process and waste management by NRB, BRC, or IGCAR. So this has already been explained by our chairman AERB. So again, just to recapitulate, this is the closed fuel cycle, and finally So our program is based on the 3-stage program which you might have studied in your training. So first stage, second stage, third stage. So first stage we are using the uranium, and NPCIL is working on the first stage right now, and second stage is for fast breeder reactor, where there is a corporation called Bhavini which is working on this, and third stage we are basically yet to work on this. In addition to this, we have had additionalities to just ramp up the power production. So we have gone for various PWR technology reactors imported from, right now it is from Russia, and we are working on importing reactors from various countries like USA, Westinghouse, or France. So as this is already again explained, so this is how the PSWR program evolved. So in 1970s, after this Pokhran blast, that was the technology demonstration stage, and then indigenization in 80s, standardization of the 220 megawatt, and consolidation in 1990s, and we went for commercialization of nuclear reactors in 2000. It was upgraded to 540 megawatt, ramp up of the capacity, and today we are working on 700 megawatt. Second stage, of course, this fast breeder reactor initially started with the test reactor, and finally we are in the process of commissioning of prototype fast breeder reactor. Third stage, a lot of things have already been done. So once we mature our technology in second stage, the third stage will basically ramp up the overall capacity in the country. So if we see the overall nuclear power scenario, so today in India, the 11 reactors are under construction of various capacities. And if we compare this vis-a-vis world, 57 reactors are under construction, and 22 reactors are in operation in India, and 438 are in the world. And this is the gross capacity. And our contribution, as explained earlier, it is 3.2%. That is from the consumption point of view, and overall in the world it is 9.8. So we have to bridge this gap. This is where our nuclear power program, expansion program is concentrating on. And we have though our capacity, installed capacity is much less, but the operation, reactor year operation is much higher, 572, because we are operating 22 reactors, of course, small capacity. And the 23rd reactor is also in operation, of course, at around 50% capacity today. So our plan is to reach, it is not only planned, we are working on this program. 22 gigawatt, we are basically aiming to reach by 2031-32, for which 10 reactors which are under construction. 10 reactors have already been sanctioned by government, which are at different stages of pre-project activities. I will come to those reactors later. And apart from this, many more reactors have been in principle approved by Government of India at around 5 new sites, wherein we can really ramp up the overall capacity in India for nuclear power. So what are the various merits of nuclear power? One is it has got huge potential in terms of base load station. Today, when there is shortage of power in the country, people simply talk about 24/7. This is what the buzzword today. People look for 24/7 capacity. They have understood how wind and solar is effective or ineffective to meet their requirement. So we had a problem of selling the power, but today it is not there. People are looking for, they are rather booking this entire power for this Kudamklon 3 to 6. People are asking to give us full 4,000 megawatt. States are asking like this. So this is the big potential about the nuclear power. And of course, base load, the requirement is there, sustainable development, energy self-sufficiency, and of course, it will give us a long-term energy security in the country. It's really safe. And this 572 reactor CS that demonstrates our capability. Today, greenhouse gas emission, this is a major challenge to protect our environment. So we'll see through one graph later that nuclear power is basically the best solution to avoid this type of emissions. This is the graph. If you see, if you compare this carbon emission from coal, it is 820 gram per kilowatt, whereas nuclear is 12. So you can see gas, even biomass, even the solar, it is much better than solar. So this is the very plus point of this nuclear power, where it is helping in protecting the environment. And our safety record says we have been operating Tarapur 1 and 2 for last 50 years. Of course, it is right now under shutdown, but efficiently we have been operating. We are not emitting almost any radiation. With this chart, we can see the natural background accepted in is around 2,400 microsievert, and the AERB has given this stipulation of 1,000 microsievert. This is more above the background radiation, and we see various sites. It is 1.57, 14, 18, 0.43, 0.48, 0.64. This is the kind of radiation is emitted from operating reactors. So nothing to worry about this. This is extremely safe. And recently, in the year 2012, one of our reactor or station was subjected to operational safety review by IAEA. So this is the impression that team has given. Open communication, enthusiasm, motivation, and sense of ownership were observed at all levels during the OSART mission. These attributes have cultivated an environment of strong safety culture at RAPS 3 and 4. So this is the certification given by independent body, how safe our reactors are. You might have studied or would be studying this various parameters on safety like redundancy while designing diversity, fail-safe systems, defense in depth approach, physical separations. These are the things which, of course, increasing our cost of the plant, at the same time giving us, assuring the country, the nation, that our reactors are very, very safe. So it's a safety sort of moving target. It's continuously evolving based on experience within the country and outside, and regulatory requirement. We are continuously improving our safety culture. And of course, we have got a very strong regulatory framework, and that is really helping us to improve our performance. So these are the various you might have seen. So starts from the fuel metric itself to the exclusion zone. So if at all some releases are there, that is confined within the plant premises. So this is what I was talking about, how much greenhouse gases it is emitting. So the year-wise, this chart is given. So if we, the latest chart is around 2019, 22, 2021. So we have, last year we have generated around 47 billion units. So in terms of million tons of CO2 emission, we have avoided around 40 million tons of CO2 in last year. So this is a major contribution. Our nuclear reactors are highly reliable. The performance of Kaiga-1 demonstrates this, continuously operated for 962 days. Around 39 times we have operated our reactors more than 1 year. So if we compare with other sources of electricity, say that it's so reliable. It continuously, unless there is, because there is some regulatory requirement, so we have to shut down our reactor after 2 years. Otherwise, if everything is okay, we could have gone for 2 years, 3 years, 4 years. And this is how, if we see the detailed chart, so you will find our reactor have been operating continuously for 400, 500, 600 years, days altogether in one go. So this is what I was talking about. Say on 39 occasions, our reactors have been operating for more than 100 days. But there are challenges also, like public perception. This is a really challenge for us, not only for nuclear power, for the entire nuclear fraternity. So we are working on this through various systems like Neighborhood Development Program, CSR activities, and radioactive waste management is another challenge, of course, as perceived by people outside. But in my opinion, we have got a well-established waste management system. Today, about entire fuel is basically reprocessed. Only some 2 to 3%, which is called waste, that is in the form of actinide. That is also now technology is there. We can burn those actinides. So as such, there is no waste. And if at all something is there, we have got a well-established system in position. And of course, we may go for deep geological repository, which people are normally talking about, the DGR. So because we do not have the substantial radioactive waste, so that is why we have not one. Once there is a sizable amount of waste, we can have this facility also available. Capital needs, it's the cost of the reactor is definitely higher, but as NPCIL, we are able to source the money from the market, no issue. But yes, we need capital, use capital, and at a cheap rate. That is most important. Land acquisition is another challenge, which not only NPCIL or DA, but all such agencies, they are facing acquisition of land. Of course, all the efforts are on to address all those challenges. Radiation, as you know, we can see around 40%, 14% radiation is taken by various medical purposes. and 85% is because of the natural reason. So it is 99. It is only 1% which may come out of these facilities. So it is almost negligible. This is what we have to tell the people, that there is no radiation hazard from emanating from any nuclear facility. These are the various steps which we, as a DA family, part of DA family, NPCIL is taking how to mitigate the misconcept which is there in the public through various media, various systems available. And this is what is the situation of the flora and fauna across our various nuclear sites. Everything is green and yielding very good results. A little bit of how our organization has developed. So we are all working under the Department of Atomic Energy. There are around 35 various constituents of the department. Part of them are part of the department, part of them are PSUs, part of them are aided institutions. So Nuclear Power Corporation, this comes under the public sector undertaking. So this is how it has evolved. Earlier it was part of DA, then PPED, Power Project Engineering Division was developed. Then later on it was Nuclear Power Board, and in the year 1987, it became Nuclear Power Corporation of India Limited. And that time we had these 6 units are operating at the time of formation of NPCIL. Today we are operating 22 reactors, and 23rd reactor is already in commissioning stage. The asset at the time was 1,313 crore. This is what was the asset, and today NPCIL is having an asset of 1,24,000 crores. Nuclear Power Corporation is a company having many companies within it. So like elsewhere in other countries, those who are exporting nuclear technology, they are having various verticals for nuclear power. But Nuclear Power Corporation in India, it is only one company who is responsible right from site selection to designing to construction, commissioning, operation, maintenance, waste management, and plant life upgradation. So everything is there in-house. So that was talent pool is available, that was technical expertise is available. So we are prepared, we are geared up for large expansion. And as has been told earlier also, NPCIL is a highly profit-making company. Last year our profit was, I will come to that later. It's a AAA rated company. So that helps us in getting the financial resources from market. People are ready to give us capital on the basis, on the strength of our own balance sheet. So at cheaper rate, we are getting almost the comparable with any company like NTPC. So it is the profile of the company gives us that much leverage. Today, as we have already told, it is 22 reactors, 10 reactors worth 8,200 megawatt. They are in the advanced stage of construction, like Kakrapara 3 and 4. Kakrapara 3 is commissioned, and some commissioning checks and some modifications are being done. So it is operating at 50%. Unit 4 is ready. In the sense, the primary heat transport system is completed. It is hydro tested, and we are gearing up for hot conditioning. And it's really, everything is ready now. Maybe another 6 to 7 months time, that should go in. That should go critical. Rajasthan 7-8 is again 85%. It is completed. Haryana 1 and 2 have already started. Kudamkulam 3 and 4 around 60% physical progress is already done. 5 and 6 we have started construction, where reactor construction has started. And in addition to this, we have been sanctioned 10 reactors of 7,000 megawatt, for which out of this, the first reactor of Kaiga 5-6, we have just started excavation at Kaiga 5 and 6. So major equipments have already been ordered, like Kalandia and Shield, and this time, I will come to that later, we have gone for the bulk purchases. And in addition to this, there are 5 sites which have been approved in principle, consisting of total 28 reactors. So this is our journey. We started, power program started with the TAPS 1 and 2. with a small capacity of 220, but that time it was, as told by Honorable Chairman, our grid was not that much stable. So 210 megawatt itself was a big capacity that time. Then Rajasthan 1 and 2 was established with the help of Canadian initially, and then after this peaceful explosion of 1974, we were off our own, and we did everything, including construction, commissioning, supply of material. Everything was done by India. So this is the latest reactor, Kudankulam 1 and 2, constructed with the help of Russian Federation, wherein their Russians role was to give the design and the design document, like specifications or the drawings and material. Construction, erection, commissioning, operation and maintenance was part of NPCIL, and this is being a totally altogether new technology. So I was part of the team there. So it was very difficult to assimilate whatever, and then the codes are different. They have got different code. They don't follow ASME. The pipes like ASTM, even the material will be different. If you want to source something from Indian market, that is not possible. If you want to source some pipe from Indian market, that will not fit into the system, which is already there. So we have to depend everything on the, so from 3 and 4, 5 and 6 onwards, we started localizing so that some of the things can be made in India. This is the overview of Kakrapar 3 and 4, where you can see 4 NDCTs are there, 2 reactors are there. It is in the commission stage. This is the total project under construction. That's I have already discussed in terms of capacities. These are the 4 sites where the reactors in fleet mode are being established, and out of this we have acquired land everywhere. Kaiga phases we have already started, and we have gone for the major packaging system, which I'll come into the project management part later on. The challenge is to how to construct the reactor in time. So we have taken certain steps. So this is nuclear sector is really, in true sense, it's Atmanirbhar right from beginning. We have built everything of our own. Our elders who are sitting there, they know it, how much pains they have taken and how they made the platform for us wherein we can really take off. And in terms of light water reactor, PWR, as I was telling, the distribution of work in case of Kudankulam 1, 2 was like this. The design, supply was part of Russian Federation later on. And in Kudankulam 3 and 4, we started taking some of the conventional system, like the chillers or electrical system. So we have taken a lot of things on our head so that the Indian market is ready to basically manufacture those equipment, those systems, and it can be seamlessly integrated with the Russian design. And in 5 and 6, the localization content has further been increased. And it's really working nice. And so the typical cost of twin unit of 700 megawatt is 21,000 crore, and the composition of the capital is 30% equity, which will be either provided by NPCIL. In most of the reactors which are under construction, like Kakrapar 3 and 4, Rajasthan 7 and 8, and Kudankulam 3 and 4, the equity of 30% is fully funded by NPCIL. We are not taking any contribution or any equity from government of India, and remaining 70% is the debt which is borrowed from the market. So in those reactors, even the 70% NPCIL is. So we have got huge capital which is invested right now. The typical completion period for 700 megawatt, we have kept around 60, to be very precise, it is 63 months. 60 months for criticality and 3 months for synchronization. So So these are the various steps, various stages in implementation of any nuclear power program. So the first stage is we should have the in principle approval by Government of India. Once the in principle approval is there, then we'll start acquiring the land. State government will acquire the land on our behalf, and we'll seek the MOF clearance. Pre-project activities will start, and then we'll apply for siting consent from AERB. So we have to do certain tabletop and site-specific studies like geotechnical studies at site, and that will give us some parameters which will tell us that site is engineerable, and we'll seek consent from the AERB, and AERB will tell us, you please go ahead. Then based on this, we'll make a proposal to Government of India for financial and administrative section. And once that is done, Government of India will approve. Then we'll start our activity. So our activity will start in phase 2, starting with the consent from regulator, that is AERB, for construction. So of course there are many other stages, but construction, it can be excavation in FPC, it can be one consent for construction. Then next important stage is the consent for equipment erection. And then once reactor is completed, commissioning has started. So various phases of ABC phases are there for commissioning. Then commercial operation. Commercial operation means we have to continuously operate the reactor at full rated power continuously for 100 hours. Once that is done, then we declare the reactor as commercial. Then we start getting the revenue from the various distribution companies, discoms. So as I was telling, so these are the various consenting processes, various approvals before construction, start of construction, after start of construction. So now the major challenge is how to reduce the construction period. This is the major challenge, because why it is challenge? Because 30% is our money, but 70% we are borrowing from the market. But market will not give us money just like that. So even today also we are getting the interest rate around 7%, 7.2%, 7.3%. So every year we are incurring certain interest component on this. So this is called interest during construction. So if we don't complete the project in time, say 5 years is the time, so the interest burden increases. That increases the IDC component. So our project overall cost is 21,000. If there is a delay of 1 year, 2 years, so that additional burden comes on that. So once that has come, then the tariff at which we are selling the power to various discoms will increase. Discom will not buy power from us because they are getting cheap power from solar. Of course, it's an intermittent power, but still they can bargain. We are getting this power at 2 rupees. Why we should buy power at 4 rupees of nuclear? So this is the challenge. The only remedy for this is to reduce the construction period. So how we have evolved the project management practices, this is just I have given here. So like Narora and before Narora, so most of the construction activities was done, most of the activities were done departmentally. There was contract, but very petty contract. So then later on, in case of Kakrapara 1 and 2, Rajasthan 3 and 4, still we had manpower. For construction, we used to have around 700 to 800 odd departmental manpower. And we used to give around 40, 50 small contracts, which were being interfaced by NPCIL. So the interface was basically causing various delays. So, and the level, this mechanization was very low initially. So delays on account of interface management, mechanization was not there. Like today, if you see, civil engineering is most mechanized. Everything is done automatically. There is nothing manual today. I would say if we compare civil engineering with mechanical, electrical, that is the most advanced technology today in India. And just one example, in case of Rajasthan 3 and 4, we used to, per day, concreting used to be around 150 to 200 cubic meter. But in case of Rajasthan 7 and 8, in one go, we could concrete around 6,000 cubic meter. This is all because of mechanization. And that concrete is also of low temperature, and we have to maintain the concrete at 19 degrees. So this kind of mechanization has reduced the construction period. And then vendor competence. Initially, it was not there. Initially, we used to develop various vendors, and a lot of handholding used to be done. Now there are agencies. Like steam generator used to be given in 6 years, 7 years time. Today, within 32 months, we are getting the steam generator. We have got all the steam generator for Haryana 1 and 2. In 36 months, that is the benchmark. So this is how the market or industry has basically come up. And next one is the camp packages. As I told, in case of Rajasthan 3 and 4, you used to have 50, 60 packages. But still in case of Tarapur 3 and 4, even in case of Kakrabad 3 and 4, Rajasthan 7, 8, we used to have around 20 to 23 odd packages. Now, what we have done is, in case of Kaiga 5, 6, we are having only 2 packages. One is conventional, other one is nuclear. So then we, from 800, our own manpower, 800 to now, we'll be operating with 40, 50 people. Very less interface, but very strong oversight. So we are working how best oversight we can provide from NPCIL, from the headquarters, from the site. So this will set up the benchmark, which already we have obtained in case of the Tarapur 3 and 4. So we want to bring it below 60 months. Criticality below 60 months. This is what is the target, and I'm sure we'll be achieving this. So apart from this, NPCIL is working on neighborhood development also. We are taking care of people who are there with us. Every year we are spending around 100 odd crores for corporate social responsibilities to build to upbring the social or economic status of people who are living with us. So this is being done in case of as per there is government policies. We are working on the medical healthcare. We are working on the education. We are working on infrastructure development. We are working on sustainable development. We are working on the skill development, so that once we give the basic infrastructure, so that people working there can earn their own livelihood. So these are some of the examples. So 100 crore to a certain area of 16 kilometers is big sum. And every year, the way our profit is increasing, it used to be around 80 crore 2-3 years back. This year it is 130 crore. So how much profit we are earning, 2% of that goes to the neighborhood development program. In addition to this, we take special approval for neighborhood development also. This is over and above the CSR. And we are taking due care for our environment also, like this biodiversity and special this medical facilities we are providing. This is how we have got one voluntary program wherein we are basically encouraging the environment, like Kudamkulam 1 and 2. When I joined Kudamkulam 1 and 2 in 2006, there was almost barren land. Nothing was there. Today you go there, you will see greenery everywhere. And the rainfall used to be around 300, 400 millimeter at that time, 2006. Now people are telling 700, 800 millimeter. And so it is all because of the efforts which were taken in the initial days in Kudamkulam. You visit all the sites, you will find this type of migratory birds are coming to Kudamkulam now. You will see peacock, everything is available in all sites. So we are taking care of our neighborhood and our environment across all the sites. Of course, Chairman AERB has already made my presentation easier, so he has told all those things. So this is what basically is the concept. The program is by 2070 we have to be net carbon emission. So for this, nuclear power is going to play a major role. And the immediate target is basically by 2030, the contribution by renewables should be 500 gigawatt. So this alone cannot be done by solar or wind. So nuclear has to come into that. So maybe by 2030 we'll not be able to contribute this much, but beyond that, definitely we are sure. For our young professionals, nuclear sector gives you really a progressive, promising future. It will give you enhanced professionalism, and you can ask your near and dear ones the attractive career profile which nuclear sector will give you, and you will really feel satisfied while working in this sector. So in the end, this is our website npcil.nic.in, and the next one is for the careers which you can recommend to our your friends, that why what are the opportunities available in nuclear power corporation, and why they should join nuclear sector in general and nuclear power corporation in particular. I thank you for patient hearing, and I hope this session should have been meaningful. Thank you very much.
Thank you so much, sir, for your illustrious presentation on the role of nuclear power in the Indian scenario. The data shared by you regarding safety and reliability of nuclear power plants is really very encouraging. The journey of nuclear power projects right from TAPS 1 and 2 till date, illustrated by you, is very inspiring. So thank you so much, sir. If there are any questions from our audience, our guests like Chairman AERB and CMD NPCIL are interested in answering. If any of you have any questions. There are no any questions, please.
No, there are concept of cluster reactor in one place. What is the maximum number you can move in one? Water is very important. In case of Rajasthan side, we have got so if we are and additional experience on water. As a restriction. Right now, we have got 23 reactors. So, in future reactors, I told that it will be imported reactor, high capacity 3 megawatt, 6 reactors of hello. What is the status of Jaitapur? Whether they will be coming or not? Site is under our position. We have permission from statutory bodies like MOE. But it's important. It's an even question. Is there any future program
like developing nuclear reactors for space.
Yes, for space.
I'm not aware about this, but we are in the process of having like various in India with government companies. But at least the nuclear power corporation is not working on such endeavors up till now. But you want to add something? ISRO. Yeah, reactor in space.
Maybe.
I think good question for you. We will think on this. The speak of this kind is possible.
So you just mentioned that so for that we are planning. We are also increasing the capacity of the reactors. So considering the fact that if we assume that all the reactors will we be able to reach that goal of 50%?
Yes. Actually, this is Panchamrit announced by Government of India. The target given by Government of India is 500 gigawatt by 2030 by non-fossil fuel. Nuclear will be one of the component. As I told, right now the program for nuclear contribution is 22 gigawatt. This is the clear-cut program wherein 8,200 megawatt are under construction, advanced stage of construction. 10,000 have already been approved, wherein we have started the activity. So this is what we will be achieving. We'll see how much we can contribute through other sources like how many reactors and all. But as of now, the contribution from nuclear power corporation up to 2031-32 will be 22 or 23 gigawatt, and remaining will come from other sources like solar and wind, biomass, and small hydro. But small hydro is more or less exhausted. But that is where we are facing the difficulty, whether we will be able to deploy that much of capacity from solar and wind because of so many reasons, space and other things.
Thank you.
This regarding this government new initiative, the collaboration between NTPC and section time further. Can I get some comments from the same?
As per this Atomic Energy Factory, Atomic Act, any two government companies or more than two companies can come into nuclear power sector. So it is basically sharing resources. As I told, 30% is our equity, 70% from borrowing. So if NTPC, companies like NTPC, and we have got joint venture. Joint venture is basically made to the capital because NTPC may get the and then we can get the expertise on project management. So it is synergy between two joint ventures. So this is the welcome step, and probably we can multiply our capacity in this endeavor. And there's more collaboration with various government companies who are cash rich.
So what's that? Thank you, sir. Thank you, sir. Thank you so much. Now we have come to the last stage of our today's program. It's my present duty to offer vote of thanks. We are very much thankful to Shri Nageswara sir and Shri Pathak sir for taking out time from their extremely busy schedules. We have made note of points in the for providing your gracious presence to join us today to enhance our joy. I am personally thankful to our Vice-Chancellor sir, Dean sir, and Shri Gatonde sir at HRDD. I am thankful to Controller BRC, Chief Administrative Officer BRC for always helping us to conduct such events. We are thankful to Shri M.G. Kelkar sir for his active coordination. We are thankful to all the dignitaries in this hall for accepting our invitation and sparing your time. This event would not have been a success without the active support of all the staff members of HBNI, especially Office of Vice-Chancellor, Office of Chairman AERB, Office of CMD NPCIL, our IT team for scheduling and managing the online meetings, creating posters, movies, posting on website, etc. I'm thankful to HBNI and HRDD staff members who directly or indirectly helped us in arranging this function. The support provided by our colleagues, Shri Dheeraj in this hall, is always wonderful. We are thankful to Shri Sadanand and Srimati Bharti Suvarna for arranging refreshment and for all their support. We are thankful to FEAJ event for covering this entire program. Last but not the least, the participants were wonderful and made this event a grand success. Thank you all. Now, on behalf of HBNI, I would like to invite all of you to join us for snacks and tea in the dining hall downstairs. Thank you.